In 1981, Szczecin shipyard delivered to Soviet Union Academy of Science a new operation prototype of research vessel, thus initiating a new series of research vessels in this yard which specializes in designing and construction of such vessels. The special outfit of the delivered ship comprises a system of arrangements for deep underwater research. These arrangements widen the scope of research by providing facilities for people to enter this environment which is still strange to us. Underwater research has made a considerable progress during last years, which was caused mainly by the search and production of oil and natural gas from underneath the sea bottoms. It is not the only reason, however. Thinking about new natural resources and new sources of food, man often turns towards sea and ocean. Systems and installations for underwater research work employed nowadays are of complex construction, requiring that man should do this task in deepest possible regions at amplest time with utmost safety. The film that shall be presented to you shows such the contraption which permits to carry out operations at the depth of 250 meters at any length of time by the two teams of the 2 or 3 divers each. The system comprises the components as follows: 3-compartment compression chamber, diving bell, pressure receivers for required gases, machinery room, chemist's laboratory, control desk, hoisting gear for handling of diving bell, shipside diving station for compressed air diving. When divers are inside the chamber, pressure is raised to the value of hydrostatic pressure as at scheduled diving depth, composition of breathing mixture being observed with utmost accuracy. The same mixture is to fill the diving bell. The team selected enters the bell, which is detached from the chamber, and it goes down. At the depth schedule, the bottom hatch opens and divers leave the bell. The work completed, divers come to the chamber for rest. They are relieved by another team. Work can be done non-stop, due to saturation effected with no decompression required upon every dive. Here is what a compression chamber and a diving bell look like. The pressure inside the chamber reads 2.5 MP. It is 9 meters long. Inside diameter 2.1 meters. It has 3 compartments. Principal compartment, 15 cubic meters. Medical compartment, 8.5 cubic meters, and cerium. The volume of the bell reads 6 cubic meters, inside diameter 1.8 meter. Underneath mounted are breathing mixture bottles, heating appliances, spare batteries and electrical power distribution box. Overall height of the bell at 5 meters. This is the transfer chamber inside. Living chamber. The living chamber accommodates 4 men and provides reasonable comfort and safety, no matter how long they would be confined there. The outfit is laid out with fair-minded construction, given the scarcity of space, the final effect ensuring much freedom. The same goes for medical room. The bell, in addition to the standard equipment, incorporates required supply of breathing mixture, recovery plant and spare batteries, thus affording 48 hours autonomy in the event of some failure. Extra oxygen bottles allow the compression effected in the bell. All supply systems and communications are duplicated for safety reasons. The bell is coupled to compression chamber by use of hydraulically controlled wedge-type ring. Individual gas ingredients of breathing mixture are kept in 400-liter vessels. The pressure in the vessels reached 20 MPa. After decompression, the mixture is reclaimed. Gas fitting and pipings of stainless steel and copper prior to installation have been chemically treated and disinfected. Prompt decompression at high pressures is feasible by provision intermediate vessels, over 3 cubic meters each. Machinery room. Connection of the pipings to the chamber. The laboratories where breathing mixture admitted from the all-over complex are tested. The samples are fed via capillaries to the test panel. Gas analyzers afford continuous readout of oxygen and carbon dioxide content in individual compartments and in the bell. Other gas ingredients, nitrogen, helium, etc., are read off the chromatograph, which also is used for retesting. The control desk covers operation of all the complex processes. All the systems are coupled to it. It gives information of the conditions prevailing inside the compression chamber and the bell. It warns of the functioning of diverse safety equipment. It provides communication with the chamber, bell and working station. Communication lines are duplicated. Broadcasters and entertainment music are relayed to the chamber. Conversations with divers are recorded.
Jak zaczynamy oddychać w trzech intensywnie, to widać podstawową tej, że ona jest podczas dechowy.
Przy oddechu powinna schodzić prawie do zera, dlatego że wy podciśnienie robicie i ten manometr po prostu jest przypadkowo na instalacji, nie? No, w takim układzie, bo on w zasadzie cały reduktor działa na mieszankę. Prawda?
Tak.
No, i on wtedy będzie działał na wysokim ciśnieniu, jak my puścimy mieszankę do oddychania awaryjnego. W tej chwili macie tlen.
Dobra, czyli słuchajcie, bawiamy się w tym momencie tak, którą ja zamknę tylko swoją dźwignią i właśnie to w tej chwili robię. Przesuwam dźwignię do okna
Tak.
i w tym momencie nasza instalacja tlenowa jest cały czas do naszej dyspozycji pod warunkiem, że odciągniemy tą dźwignię. Zgoda?
Zgoda. Cały ten układ to jest awaryjny,
Układ,
nie?
ale tylko pytanie.
W tej chwili macie jako tlenowy działa.
Mamy tlen.
No i tak na razie zostawiamy.
Zostawmy tak tlen. Dobra.
Ample compartments afford congenial atmosphere for work and relaxation.
Nie spadało do zera, to wystarczy.
To jest taki kapturek nałożony tam. Jego można ściągnąć takim ruchem jakimś w górę, w kierunku góry. I tam jest czworokąt na klucz.
A, no tak, ale ja miałem klucz.
Tak. I w wypadku, kiedy opory oddechowe
Wydechu, dobra, to
byłyby ciężkie, to tym się reguluje.
nie jest ciężko, na razie nie będziemy regulować.
Czyli
To jest, z tą instalacją mamy wszystko, sprawdzone są wszystkie maski. Wszyscy to gdzieś tam obie maski. Zaraz, moment, jeszcze, zaraz to używamy wszystko.
Hydraulics handle the diving bell carefully. Within few minutes, the divers will be busying themselves about their tasks down there. The system presented has been designed and constructed in Szczecin as the first system of this type in Poland. Both the owners and the classification society have been much appreciative about the project that is doubtlessly quite an achievement in the world marine engineering. The system contributes to uncovering some mysteries that have remaining hidden hitherto.